All right, non-fungible tokens. We've mentioned things like ERC20 and ERC777, the newer version of ERC20. It's an Ethereum recommendation, but it's basically a standard is how they do it. And those are for fungible tokens. So what's the difference between a fungible and a non-fungible token? Fungible tokens are all the same. As in, if you give me $1 and I give you back $1, it still has the same value to you as the original. Now, if I take the original, take a lighter and burn it, and then hand you a brand new dollar bill, it's still the same dollar. You got back your dollar. That's fungible. It's not unique to any one thing. A non-fungible token has some sort of a unique value to it. It has an ID. It can be identified individually. Now, what we've seen recently with non-fungible tokens is that tied to some artwork, somebody sold some piece of artwork with a non-fungible token for it was either $63 or $69 million recently. Now, why does this make the non-fungible token, why did it make the art more valuable? Because art's been plagued with forgeries for ages and thefts. And how do you know that the piece of artwork that you have is actually an original, that you are actually the owner? And that's the question at hand. There's been instances in the past few years of entire museums that had collections of art that found that half of their artwork in the museum was forgeries. Or that they have a piece of art and they find out that they don't have the original, that they paid a great deal for it, but it isn't actually original, it's a copy. And people go to a great deal of effort to make copies. I think, in terms of forgeries, the most recent thing is the millions of dollars that have been spent on pieces of Dead Sea Scrolls that turn out to be very clever copies that are fake. And entire museums that have collections with dozens of pieces in it that all turn out to probably be fakes. So you can't trust that these things that you think are good are actually real. So the non-fungible token gives us a way to identify the actual ownership and authenticity of a piece of art. Now, this entire authenticity and proof of provenance, of where it came from and how it got to be there, is hugely valuable in a lot of things. We've talked some about supply chain and applying it to other things besides artwork. But in the art world, it's turning out to be a hugely valuable thing. Now, in the land of Solidity and Ethereum, OpenZeppelin has a non-fungible contract called ERC721. It's based on work done by Kitties, and they are collectible cats that you can actually breed and produce new cats. And yes, I own 2 completely worthless Kitties that I bought. Not for very much, but I wanted to understand how it worked, and it took 2 of them before I understood. So yes, I bought some Kitties. It's embarrassing. They're worth less than what it would cost to sell them, but I own a couple of these digital cats. So this is where this contract comes from. And what do CryptoKitties look like? Well, they look like these things. They're digital cats. I suppose on the good thing, that it's it being a digital cat, you don't have to feed it or deal with a litter box. But on the bad thing, it's just a collectible. It's an image of a cat with the ability to take ones with certain characteristics and breed them together to get new children from that breeding process that produce more cats, which you can't do with baseball cards. You can't breed 2 together and get a better baseball player. So there are some unique things, but CryptoKitties is the origin of our ERC721. Now, I've taken the OpenZeppelin stuff here and made a very rudimentary 721 derived contract called Grouse Credit. We have a need for environmental credits, and I've created the minimal Grouse Credit here that basically says that I'm going to, create this credit, and the only thing it has going for it is mint. It should have a constructor in here too, but this is basically going to give us, this is how you create a credit, this is how you inherit from this thing called ERC 721 storage, and inside we have token IDs that we increment. So guess what? Our unique non-fungible token is a number that counts up in this case, that when we count up and get the current value, we mint it to this ID. So we're going to create this new token that's minted. And we've got this other thing that turns out to be the real power of this, which is this token URI. So we pass in for this ID a URL that has whatever ID information in that URL that we want to save with the token that says that here's how you get the outside information for this. And there's a call in the contract that says, for this ID, give me the URL that matches with it. And if you go look up that particular URL, you can find out, well, here is the data, usually in JSON format, that's associated with that particular item. In the case of the CryptoKitties, there is information in there that allows you to draw the picture of the cat. So you can actually look it up and get a picture of your cat. So here we're talking about something like a CO2 credit or something like that, where, you've got a bunch of information that you want associated with it, like when the CO2 was sequestered, who did it, and, you may have other information about, is it signed, is it validated, is it authentic, but between the two, the information that's stored in the contract and the outside information, you've got enough information to pull up the data on this token. If this were a piece of artwork, it would probably include an image, maybe a link to the original image for the artwork, if it were digital artwork, but an image that says that, yeah, here is, for this non-fungible token, here is what this thing represents. For things like non-fungible tokens, ERC 721s on a piece of land, it needs to have information like, here's the title for this piece of land. Here's where this subdivided or chunk of land is. What is the location of it? That's the kind of information that we store in the external data associated with this token. Now, we're going to take a walk through what is in the ERC 721 standard. The first thing you're going to notice is that it has nothing to do with the price that you buy and sell this for. We're also going to take a look at a decentralized bid operation here in a little bit. That is how you buy and sell these tokens. But the ERC 721 this is the interface to control what the token is. This is the interface to approve the sale, to say that yes, somebody can buy this. This account has the right to purchase this token. Okay, usually they've paid for it, and then you give them the right, and then they can transfer the token. So there's more than one step in the payment process. But if we go look at the non-fungible token standard, okay, and this is Ethereum's site, and it actually has the standard that they agreed to, that you'll see that for this standard, there is some motivation on why they would want something like this as opposed to an ERC 20. I think that's fairly obvious if you're going to track outside things. And then it goes into a specification that basically says, here's how we approve a transfer. Approve for all says that that the destination is approved to take all the tokens that you own. Generally speaking, that's not used in this context. A transfer. Interestingly enough, transfer matches with the ERC 20 standard and is almost never used directly inside an ERC 721 because there are certain security risks. Instead, there is a safe transfer. And the safe transfer verifies that the receiver can actually receive this kind of token so that you don't send the token someplace where it can never be retrieved from, essentially burning the value of the token. So although there is a transfer, the safe transfer is the one that gets used. Then there are two flavors of the safe transfer. Notice that the function is the same, but the parameters vary, so it is overloaded. One has data, the other doesn't. The data here in the just regular safe transfer without data, an empty string is passed, or 0 bytes is passed as the data. So there's not much difference between those two. One calls the other. And we can find out how many tokens an individual owns. Like if you did balance of given my address on Ethereum for CryptoKitties, you'd find out that the answer would be 2. I own 2 CryptoKitties. Completely worthless CryptoKitties, but 2. You can find out if you looked up my token ID, which I have no clue what it is. I'd have to go look up my token ID now. That if you picked that token ID and sent it into CryptoKitties, you'd find the address, which is the address of me, the owner of those two CryptoKitties. And the approval. Now, when you think about it, somebody sends you in the bidding process or the sale process. You listed it, sold it at a fixed price. They bid it on it. They won with the bid. That after they win the bid and transfer to you the value that you are asking for or expecting or surprised to get because they bidded way higher than anyone else, that you then approve that person to be able to receive the token. And then they make the call after they're approved to be able to get that particular item. Okay? So these approval and get approved have to do with transferring individual tokens. Now, a ERC 721 matches with an ERC 165 interface so that it can verify that this interface is supported for people like the exchanges. Like, I can't think of the name of an exchange. Kraken is one that's here locally in Laramie. But this is the interface that they're expecting. And if you get your token listed with them, or your bid process, it checks that it matches this ERC 165 interface specification so that it can be queried and support that interface. And that way, they don't try to sell tokens to something that doesn't support an interface that they work with. That's their piece of it. A token receiver. Now, if you transfer tokens from one contract to another contract, the receiving contract has to have the ability to handle these tokens. So remember, there was the just transfer and hope for it that it works, and then there's the safe transfer. The safe transfer has to do with this, is it supporting an ERC token receiver? So that it can actually receive these tokens and store them and later transfer them on to somebody else if you ever decide to use them. And then there's the metadata. And the metadata is a couple names, a name and a symbol, and this token URI. Now remember I said, if you ask the contract for this particular token ID, it will send you back an URL, a universal resource indicator that says, here's how you display the information for this token. And this is different than you would get in an ERC 20 or ERC 777 contract because those things are fungible and you can't differentiate between one and another. It's just a count of how many you have. Here you pass in the ID. And for that ID, it says, here is the matching place where you go get the data. And they've given you a sample in here in their specification of what you might have for data. Okay? And their data is a lot bigger than mine, but again, you notice that they've said you're probably going to return to the front end some piece of JSON data that gives, strings and information and description and stuff like that on this particular thing. What you would expect is that you would have some sort of a web interface that says that if you put in your ID or you have a list that you've stored of your IDs, something like that, for your IDs for these non-fungible tokens, the tokens themselves, you would have some sort of thing that you can click on and it will tell you the information in a human-readable, nice format instead of just JSON data for that particular thing. So the web front end would go out, use that URI to go fetch back the data and then say, I'm not just going to display to you this number, which is your CryptoKitty. I'm going to give you the interminably cute picture, just like that right there, of a beautiful kitty with a smile on its face. So that is kind of the level of things that you would see in it. And there is also this optional thing called enumerable. Now, if you keep an external list of what your tokens are, that is good. But, sooner or later somebody's going to lose their list and say back to the people who did this, can you list out what my tokens are for my account? And it turns out that there's nothing in the standard ERC 721 interface that says, here is a list of each person's tokens by the owner. So this extra enumerable contract is that. It has a total supply, which is a count of all of the tokens. It has an index, which, starts out at 0 and you count up the index. And it returns the ID of the token. And you can also ask for a particular owner, okay, an index, okay, to return information about that token, okay, if it's assigned to an owner. So the reason for this enumerable is that the tokens themselves are stored in a solidity map. But a solidity map has no way to iterate over that map. So you can't do like in JavaScript, you can take a map and you can iterate over the keys. That option doesn't exist. So if you want to be able to get back these things, there has to be extra storage, basically an array that gets stored as a separate item and is going to cost some extra gas, ether, when you create the token and when you want to fetch it back. But once you have this list, the local requests to enumerable are very cheap to be able to say, okay, go through and list me back the tokens one by one so that I can scan down through them and I can find all of the tokens that exist, find the owners, get the indexes of these things in each case so that I can get back a list of them. And for any practical application that I can think of, at least, I don't think there's a case where you wouldn't want to have enumerable implemented in conjunction with your ERC 721s. So that you can not just do this, but it makes a lot of sense for front ends that somebody's going to want to say, okay, give me my list, okay? And you can actually list out the tokens, and then they can click on that list for their individual tokens to find their individual data. Expecting the users to keep their own independent list seems very problematic. So this is a good thing. Now, that's kind of the interface. Now, as I've gone down through this, I've hinted at the fact that this isn't the buying or selling of tokens. We're going to talk about that a little bit. This is just, here's how I'm going to represent a token. Here's the data I'm going to keep about it. And here's the interface that people can use to get to it.